Hey, fellow problem solvers, Colfax Math here. Today we're going to talk about an introduction to algebra and do some practice problems for the ASVAB military placement exam. We're going to look at both arithmetic reasoning, which are usually word problems, and mathematical knowledge, kind of more your classic high school math knowledge. This is from my book, Math Test Success. You could get it on Amazon. I'll put a link to it. In this book, I have all these chapters and I have a video for every chapter, but I have also split this book into 5 separate parts. I was going to do 5 videos just to condense the whole book into a single set of 5 videos. The last video is Foundational Skills and Arithmetic Review. This video is part 2 of the book, Introduction to Algebra, chapters 6, 7, 8, and 9. So it's going to be a pretty long video. We're going to talk about basic algebra, the difference between expressions and equations, what a variable is. We're going to look at inequalities, and we're going to look at some real-world word problems, algebra problem-solving problems. It'd be great if you had the book and you could work through the book. This is kind of set up so that you could take your notes alongside the book and then do the problems in the book, pausing the video, doing the problems before I do them, unpause the video, and watch how I do them. If you don't have that book right now and you're ready to study this algebra portion of the book, make sure you have paper and pencil out in front of you. Still pause the videos, do the problems before I do them, unpause, and then see how well you did. So with all that said, let's jump all the way ahead here to chapter 6. So we're going to go chapters 6, 7, 8, and 9, these 4 topics here. And so it's going to make for a pretty long video. Right, in chapter 6, we're going to talk about variables and expressions, the difference between a variable and a constant. A constant is just a number like 5 or 17 or a half. A variable is a number that you don't know what it is. It's like saying this thing plus 5 equals 10. What does this thing have to be? Well, what plus 5 equals 10? So this thing, the variable, has to be 5. So that's what a variable is. It's used all the time because when you're ever looking for something, you assign a variable to say that is what you're looking for. This is an expression right here. When I have no equal sign, so if I have something like 3y minus 7, there is no equal sign in this, so this is called an expression. This right here, the y, the unknown, is my variable. The 3 and the negative 7, those are my constants. I could have an equation, an algebraic equation. Area is equal to pi r squared. R is my unknown. It is my radius of a circle. I could tell you the radius and you could plug it in for that unknown. Pi is actually a constant because it represents a number 3.14. So because it's a Greek letter representing a number, that number is still a constant. And then a series of constants and variables together is called an expression. An expression set equal to something. Now this is an equation. So once I have an equal sign in there, then it becomes an equation. Equation equals sign. Okay. A lot of this is vocabulary, and you just kind of need to know some of the vocabulary. Transferring words into expressions or into equations. So some of the words you'll see a lot of is sum, plus, increase by, more than. Those all mean to add. Other words that mean subtraction, difference, minus, decrease by, less than, multiplication, product, multiply by. Those are all the words to kind of tell you what operation to do. So let's do a couple of these problems right here. Let n represent the number of apples. Write an expression for the number of apples plus 5. Well, the unknown is the amount of apples I have. Is telling me let the letter n be that. So the expression, the number of apples, n plus 5. Number 2, let x represent a student's score on a test. Write an expression for twice the student's score. Well, x is a score. Twice means times 2. So an expression to represent twice the student's score is 2x. The sum of a number and 7. I don't know what that number is, so I call it x. The sum of a number and 7. That's the translation from the sentence to the expression. Write an algebraic expression 10 less than a number. So whatever that number is, it is 10 less than that number, so subtraction. So that's just a little, some of the vocab words you need to know for converting a sentence into an expression. Okay, in an expression, there's no way to solve for x or the variable, whatever it is. But a lot of times you have an expression like this, and you need to combine all similar terms. So this is saying 4x plus 2x minus 1x. Think of it as I got 4 apples. I got 2 more apples, so now I have 6 apples minus 1 apple. So this is going to be, I have 5 of them, or 5x. I can only combine similar terms, meaning I could only add y's and y's together and constants together. I could only combine similar things. You could only add apples and apples. Apples and oranges is still going to be 7 apples plus 3 oranges. You cannot combine them. I know I might be making it a little too simple, but we're going to just build on these skills throughout all of this math. These are just the foundational skills in algebra you have to know before you move on. So pause it and do a couple of these, and then I'll do them. Okay, 3y minus 1y is 2y. That's a 2. 2y. 5 plus 2 is 7. Here I have 6a plus 3a. That is 9a. Minus 2b plus 5b is 3b. Again, all I'm doing is simplifying the expression by combining similar terms. Simplify the expression. This is 7x times 2, I think. So this would be the equivalent of 14x plus 3x. This is negative 2 times 2, but this is an x right here. It's the same look at that. So it's negative 2 times 2 times x is negative 4x. And then I have that x at the end. Now that I've kind of multiplied these things together, 7 times the 2 to get the x, the negative 2 times the 2 to get the negative 4. I have 14x minus 3x, 11x. 11x minus 4x is 7x. 7x plus 1x is 8x. How many x's do I have? All combined, it works out to be 8 x's. Let's keep moving along here. And then here's a test for chapter 6. I won't do all of these. We'll just do some of these. But let me just do a quick translation again of some of the key words. First thing is a variable is an unknown, usually represented with a letter. A constant is just a number. An expression is a series of terms being added or subtracted. An equation has an equal sign in it, and you can do whatever you want to both sides of the equation to solve. In an expression, you could just simplify and combine similar terms. Product is multiplication. Divided by, you'll see for division. The sum is addition. The difference is subtraction. Okay, let's do a few of these. What's a variable? It is an unknown in a mathematical expression or equation that's usually represented by some sort of letter. A constant is a number. Write the following phrase. The product of 7 and a number, I don't know what that is, so I call it x. The product is multiplication. So the product of 7 and a number decreased by 5. Evaluate the expression given that these variables have values. The way you do this is you take that 3 and you plug it in there for A. You take that negative 2 and plug it in there for B. Order of operations is you got to do exponents before multiplication. So 3 times 3 is 9. 9 times 2 is 18. Minus 3 times negative 2. So this is going to be 18. Negative 3 and negative 2 is 6. 18 and 6 is 24. I haven't solved for anything. There is no equation here. This is only an expression. I have variables and constants, but I am giving you values for those variables and plugging them in. Let's move ahead a little bit more. Number 6, a rectangle has a length of w plus 5 and a width of w. So I have my rectangle like this. It has a length of w plus 5 and a width of w. Write an expression for the perimeter. Well, perimeter is the distance around the outside. If that's w, that's w. That's w plus 5. That's w plus 5. I need to add all 4 sides together. So I have 1, 2, 3, 4. 4 w's plus 5 plus 10. So an expression for the perimeter would be 4w plus 10. The area would be base times height, and you get into some squares. Number 7, pause video, give it a try. Take 4, plug it in there. I have to do my parentheses first. 3 times 4 minus 2 gives me 2 plus 5 times p, and p is 4. So this is a 5 times that p, but we know p is equal to 4. So I'm plugging that 4 in there and there. 3 times 2 is 6. 5 times 4 is 20. So the answer here is 26. Let me do one more here, and then we'll move on to the next chapter. John has 3 times as much money as Sarah. So I got John and Sarah. Write an expression for the total amount of money they have together. Okay, so Sarah has D dollars, and then John has 3 times as much money as Sarah. So whatever Sarah has, let's say she has $5, he would have 3 times that, $15. So his amount of money is 3 times the number of dollars Sarah has. Sarah has D dollars. John has 3 times as much money as Sarah. Write an expression for the total amount of money. So the $3 John has plus whatever Sarah has, 1D, is a total of 4D. Pen's kind of going slow. That's a 4D. All right. Hopefully you're still with me. Here's the answer key to all of chapter 6, and that's going to bring us to chapter 7. So one more quick recap on the couple big ideas. In chapter 6, a variable, a constant. The 4 operations have words associated with them. The difference between an expression where there is no equal sign, I could only simplify, and an equation where I can solve. So chapter 7 is all about equations. Now I have this equal sign in my equation. So now what I could do whatever I want. I think of this thing right here, this equal sign is a balance, and that's a good way to think of it. So this equal sign right here, x plus 5 equals 12. This is a balance, and this thing's perfectly balanced. I could do whatever I want to this balance as long as I do it to both sides and it stays in balance. So if I add a million here, then I add a million here. If I divide this by 10,000, I divide this by 10,000, it is still equal. It's still in balance. So if I want to get x by itself, well, if I subtract 5 from the left, I could do that as long as I subtract 5 from the right. My 5's cancel, gives me x by itself. 12 minus 5 is 7. What I'm saying here in solving this equation is I'm coming up with the value for my variable. The check is I could take it, plug it back in, and 7 plus 5 equals 12. So not to overdo a point here, if I have something like a half plus a quarter, this is an expression, this is an equation. I can't do whatever I want to both sides because there are no both sides. The only thing I could do here is multiply by factors of 1. I would multiply this by 2 over 2. I am multiplying by 1. That gives me 2/4 plus 1/4. I have that common denominator. I add across the top, keep the bottom the same. This is an expression. The only thing I could really do with expressions is multiply by these factors of 1. With equations, I could do whatever I want as long as I do it equally on both sides of the equal sign. So the point of these problems is to get that variable by itself. So pause the video, try and do some of these. And the way you're going to do these is get the variable by itself by doing the opposite operation. Okay, so y minus 3 equals 8. I'm going to add 3 to the left, add 3 to the right, give me y equals 11. It is a reverse operation. I want to get rid of that negative 3. So I add 3. That gives me y by itself. 4a equals 20. I am multiplying by 4. So I divide by 4. A is equal to 20 divided by 4, or 5. Multiplying, so I need to divide both sides by 2. B is equal to 3. Subtract 9 from both sides. M is equal to 24. Add 4 to both sides. P is equal to 15. Divide both sides by 6. X is equal to 5. And really what I'm saying is 6 times 5 equals 30. Divide both sides by 3. Okay. So now we're going to start looking at, sticking with equations. Chapter 6 was expressions. Chapter 7 is equations. We're going to do a few more steps and then add in some fractional decimal portions of it. So we do PEMDAS, parentheses first, exponents, multiplication, division at the same rate, left to right, then addition, subtraction, left to right. So I do the reverse operations when I'm trying to get that thing by itself, right? So I'm trying to get that x by itself. I can't divide yet because I got that 3 there. So I'm going to subtract 3 from both sides. That's going to give me 2x. 3 minus 3 cancels. 7 minus 3 is 4. Now I am multiplying. I have to reverse by dividing. Divide both sides by 2 and get x is equal to 2. I have a value for my variable. I'm not sure if it's right. I could take it, plug it back in there. 2 times 2 is 4. 4 plus 3 is 7. 7 equals 7. So I could see I did it correctly. Okay, next one. So that's a 2-step equation. First subtraction, then division. 2-step equation here, but we got a decimal. I'm going to add 1 to both sides. So this is 3 plus 1. So I'm going to add 1 on this side. So I'm going to have 0.2y is equal to 4. I don't know if you can read that. 0.2y is equal to 4. I got to divide both sides by 0.2. 0.2 divided by 0.2, these cancel, giving me my variable by itself. And I got to divide this by 0.2. What I'm saying here, this fraction falls over this way. I'm saying 0.2 goes into 4. I don't want the decimal there. I'm going to move it over 1. Decimal's here. I move it over 1. And then bring it up. 2 goes into 4 2 times, giving me 4, 0, 0. And my answer is 20. So how many times does 0.2 go into 4? It goes in there 20 times. Y is equal to 20. All right, hopefully those are making sense. If the decimals are a little unclear, go back to the first video, Foundational Skills, where we do addition, subtraction, multiplication, division of decimals. Do these practice problems. Add 2 to both sides. 4x is equal to 5. Whoops. 4x is equal to 5. Divide both sides by 4. X is equal to 5/4. That's a good answer. Or That's an improper fraction. I could convert that to a mixed number, 1 and 1/4. Okay, some solutions here. And then here's our test on chapter 7. Hopefully the video is paused. You did some of these. I won't do all of them, but I'll do some of them. So solve for x, my first equation. I'm going to add 12 to both sides to get x equals 17. 3 times y equals 21. Divide both sides by 3. 21 divided by 3 is 7, the value of y. Two-step equation here. I'm going to subtract 7 from both sides. That's going to give me 2m. 7's cancel. 15 minus 7 is 8. Divide both sides by 2, and m is equal to 4. Add 3 to both sides. 4p equals 12. Divide both sides by 4. 12 divided by 4. P is equal to 3. Okay, let's do a couple of fraction decimal ones. Let's do this one right here. 0.4 y minus 1.2 is equal to 0.8. Still isolating the variable y, I add 1.2 to both sides. That's going to give me 0.4 y equals 1.2 plus 0.8 is 2.0. Divide both sides by 0.4. How many times does 0.4 go into 2? Think of that fraction falling over this way. How many times does 0.4 go into 2? Got to move that decimal over 1. Decimal over 1 to give me 20. 4 into 20 is 5. So this answer right here, y equals 5. Make sure you do all of these problems. And then the solutions are down here below. And then we'll move on to the next chapter. If you're still with me, good job. So again, chapter 6 was expressions, no equal sign. You could only modify it by multiplying by factors of 1. You got a lot of those word conversions to expressions, combining similar terms. Chapter 7 was an introduction to equations, 1-step, 2-step, 3-step equations, integrating in fractions, decimals, and percents, solving equations, isolating the variables. Now we're going to start looking at inequalities. Equality means equal. Inequality means not equal. So we have expressions, equations, now inequalities. So in inequalities, this thing right here means less than. So I could say x is less than 10. And there's an infinite number of values that'll work. 9 is less than 10. 7, negative 20, those things are all less than 10. Or I could say x is greater than 10. 12, 15, a million, anything greater than 10. And then we also have less than or equal to. So every number would be included if we had x equals 10, an equation, and everything less than 10 and everything more than 10. But I could combine the equals and the unequals together, and that's going to give me less than or equal to. Okay, so this right here, x is less than 5. If I want to draw that on the number line, here's my 0, here's my 5. It is everything less than. I use that open circle to say non-inclusive of 5. So what that looks like is an open circle to say not including. If I wanted to include that and make this x less than or equal to, then I color in that circle. Same color, but it's colored in. That's true in one-dimensional space with only one variable. It's also true in two-dimensional space when you look at y and x on the Cartesian coordinates. If you have a solid line, it's inclusive. A dotted line means non-inclusive. So this equal sign is saying including 5. So let's go ahead and convert a lot of these words right here to inequalities. A number p is less than 10. A number q is greater than or equal to -4, like 0 or 100. A number u is no more than -8. So a number u is no more than -8. So let me see if that makes sense. A number u is no more than -8. So a value here could be -10. Is -10 no more than -8? Yes, it is. So therefore, I've written this sentence in an inequality correctly. These are kind of hard conversions. A number x is not greater than 7. Not greater means it has to be less than 7. Not sure if I got that right, so let me pick a possible solution to my expression, my inequality, like 0. 0 is less than 7. A number like 0 is not greater than 7. Is not greater, so 0 is not greater than 7. It's hard converting these words. A number z is strictly above 12. Z is greater than 12, like 13. 13 is above 12. Yes, it is. I did that correctly. So if you're having a hard time with these, write out what you think it is, and then pick something in your solution set and see if it holds true for that. Let me do one more. A number w is fewer than 0. So a number w is fewer than 0. Something less than 0 in this expression, inequality would be -2. -2 is fewer than 0. Correct. So I did that one correctly. All right. Solving and graphing linear inequalities. Before we even start on these linear equalities, there's one really key thought before you treat these things like an equation, right? So chapter 6 expressions, chapter 7 equations. Now we're looking at inequalities. You're going to solve inequalities just like an equation with one exception. If I have -5x is less than, greater than, less than or equal to 10, this is a key idea right here. So pay attention to this one because it's a crazy rule. If I multiply or divide by a negative, I reverse that sign. So I'm going to divide both sides by -5. These will cancel. That'll give me x by itself. I reverse that sign. It now becomes greater than -2. So one more time, if I multiply or divide by a negative, my inequality gets reversed. Okay. So let's do a couple of these practice problems. You're going to treat it just like an equation. So on this one right here, I would add 2 to both sides to get a is greater than 7. Divide both sides by 3. B is less than or equal to 3. Do this one in blue. Make sure you get this one right. Divide by a negative. As soon as you hear that, you're thinking, ding, 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 ding. Right? X is by itself. It is less than. It is now greater than. 12 divided by -4 is -3. And that kind of makes sense too. If you take those values, like a value greater than -3, like 0, say, plug 0 in there, 0 times -4, 0 is less than 12. What's another one? What's the number? 10. 10 is greater than -3. 10 times -4 is -40. -40 is less than 12. And that's why when you multiply or divide by a negative, you switch that sign. That is really a very big part of the math knowledge. Like those little tricks you need to know in math, like when I multiply and divide by a negative, I reverse that sign. Right here on this one, -3x plus 5 is greater than or equal to 20. Subtract, 3x plus 5. I subtract 5 from both sides. -3x is greater than or equal to 20 minus 5. Divide by a negative. Divide by a negative. Come on, pen. Divide by -3. These are going to cancel. X by itself. I divided by a negative. I have to reverse that. 15 divided by -3 is -5. All right, let's take a look at some of these word problems here. So these are words to convert into inequalities. The sum of a number, I don't know what that is, so I call it my variable x. The sum of a number and 5 is no more than 12. So that means less than 12. The sum of a number and 5 is no more than 12. No more means less than. A value is no less than 7. That means that value has to be greater than 7. Okay, here's a chapter test. Pause the video, work your way through these. I won't do them all. The key is in the book. Then we've got chapter 9 still in this video. If you're still with me, fantastic. If you're new to the channel, think about subscribing. The whole goal of this channel is for you to do as well as you can on any standardized math exam, specifically the ASVAB military placement exam. And I really only focus on math. I have some other videos on the other test sections, but math is really the key. Okay, let's go ahead and take this chapter test. I'll just do some of these, and then we'll see how we go. Write an inequality for a number. I don't know what that number is, so I call it x, is greater than -3. A number is less than or equal to 8. A number is at least 5. These are always hard. So a number is at least 5. So I think it's greater than 5. I'm going to pick a number like 6. 6 is at least 5. That is true. Solve and graph. These are graphs on the number line. First thing I'm going to do on x plus 5, greater than 10. Isolate my variable x by subtracting 5 from both sides. X is greater than 10 minus 5. On my number line, here's my 0, here's 5. It is greater than that, but not including it. Open circle, going that way. Jump down to number 8 right here. So on number 8, I have -3b is greater than or equal to 9. Divide by a negative, change that sign. Divide by a negative, change that sign. B is less than or equal to -3. So I would have labeled this previous number line x. This one I'm going to label B. It is less than or equal to -3. Here's 0. Here's -3. It is also equal to it. Closed in dot, going that way. Closed in dot, going that way. All right, let's move down to some of these word problems. I had a comment that I need to do more algebra word problems. Hopefully this video is helping that. The sum of a number and 7 is less than 15. So I've taken that sentence, converted it into an inequality. Write and solve the inequality. There it is. Now solve it. Subtract 7 from both sides, and x is less than 8. 15 minus 7. Twice a number is at least 10. I always got to leave it blank. Is at least 10. So twice a number has to be greater than 10. Divide both sides by 2, and x is greater than 5. A number, I don't know what it is, so I call it my variable x, decreased by 4 is no more, which is less than 6. We solve that, add 4 to both sides. X is less than, adding 4 to both sides, 10. So let's think if this makes sense. Let's pick like 0. A number like 0 decreased by 4, -4 is no more than 6. Well, -4 is no more than 6. So I can see I did that one correctly. Again, finish this test. Key is right down here. And that's going to bring us to chapter 9. word problems. All right, this is going to be the last chapter in this video. Hopefully you haven't gone too long. Hopefully you're doing these problems along with me. All right, let's get started. The key on word problems is being able to take that sentence or multiple sentences and decode it into an equation or an expression or an inequality. I like to circle the key words and then translate them. But here are some of the keys. A number or unknown quantity, that is going to be your variable. The sum means to add. The difference, subtract. Product means to multiply. Really small little x or a little dot means to multiply. The quotient of, division, or a slash mark means division. Equals, results in, is, all three of those words means equals. More than, increased is addition. Less than, decreased by, subtraction. Twice, double, 2 times. Half, half of. Half multiplied by half or divided by 2. Percent of, mean 100% times that value. Okay, moving up here. The sum of a number and 5 means x plus 5. Twice a number less 3. 2 times, twice a number, no, I don't know what it is, so it's my variable. Twice a number, 2x less 3. 15% of a number is 30. I convert that to a decimal, 0.15 of a number, x, is equals 30. So here's my 6-step process. Read it very carefully. Read the entire problem. Identify the unknown. What is it you're trying to look for? Translate that phrase, break it into smaller phrases and translate it into an expression. Form the equation. Solve the equation, and then check your answer. Okay, so here's some examples. Let's work through this example, and then we'll do some practice problems. So right here, 5 times a number. Well, this I know right here is x, because I don't know what it is. 5 times a number. This is multiplication. I'll put it as a dot. Decreased means negative by 7 is equal to 23. So I have 5x minus 7 equals 23. So I've kind of highlighted the key words. 5 times a number. Decreased by 7 is 23. So I've created my equation. Now I'm going to solve my equation. I'm going to add 7 to both sides to get 5x by itself. 5x equals 30, 23 and 7. Divide both sides by 5, and x is equal to 6. I know this is really a long video, but you could see how you got to start with really foundational skills, all of the multiplication, division, addition, fractions, decimals, then look at expressions, then look at equations, then look at inequalities, and then take all those skills and apply them on these word problems. If you don't have those bases, the word problems are really hard. Okay, let's go ahead and do a few of these practice problems. Right here, 6, here's a key number, whoops. 6 less than 3 times a number. I don't actually see any equals in there. So this is not an equation. It is only an expression. 6 less than 3 times a number, 3 times a number. So I have 6 less than 3 times a number. So number 2 here is 6 from 3 times a number, 3x minus 6. The sum of twice a number, the sum, so I'm going to add, twice a number and 10 is. This is saying equals. So I got is 30. That's equals 30. Let's figure this out. The sum of twice a number, I don't know what that number is, so I'm going to call it x. 2x. The sum of twice a number and 10 is 30. Now I'm reading this back and forth a lot. Hopefully you're able to break it down. One of the key reasons why math is so important, it allows you to take these pretty complex problems and break them into smaller and smaller pieces so that you could solve. And that's why the military is looking for a strong math score. It's an indication that you could take complex problems and break it into pieces on paper. Okay, so I have my equation. Subtract 10 from both sides. 2x is equal to 20. Divide both sides by 2. X is equal to 10. I think I'll stop there and we'll move right on to distant rate problems. If we don't keep going here, we'll never finish this video. So these are really common both in arithmetic reasoning and mathematical knowledge. The key is distance is going to be equal to your rate times your time. If you look at the units here, it'll kind of make sense. Let's say your distance is in miles. Your rate would be in miles per hour. Your time would be in hours. And this is how you do your unit conversions. I could see this is multiplying fractions. These would cancel, and I could see miles equals miles. So distance equals rate times time. You could divide this equation by both sides, however you want, and re-represent it as time equals distance divided by rate. Rate equals distance divided by time. They will all work. Because it is an equation, you do whatever you want, as long as you do it to both sides equally. Okay, a rectangle has a length of 5 inches longer than its width. I don't know what that width is. I'm going to call it W. The length is whatever that width is plus 5. If the width is W inches, what is the length? W plus 5. Number 2, a plane flies 500 miles per hour. That's going to be my rate for 3.5 hours. I multiply it by 3.5 hours. How far does it travel? That is asking for the distance. So the distance will be this, and I could see here that hours will cancel and leave me with miles. 500 times 3 is 1,500 miles. And then 500 times 0.5 is 250. So it's going to give me 1,750 miles. This is the equation. Remember, distance equals rate times time. I have to have 2 of those to solve for the third. Okay, interest problems. Go here to simple interest. So the key on simple interest here is very similar to our, we had distance equals rate times time. That's just an equation you need to know. The one for interest is equal to the principal, the amount in the bank, times the rate that you're receiving times the time. This is considered simple interest, meaning that I am not compounding it, earning interest on my interest. You can compound yearly, monthly, quarterly, hourly, continuously, but we're only looking at simple interest. So if you see that expression simple interest, that's what you're going to do here. So Sarah invests $2,000 in a bank account. That is her principal. She earns simple interest, so I'm using that equation, 3% per year times 5 years. So the interest she earns will be equal to her principal, $2,000, times her interest, 3%. I think of that little arrow shooting the decimal over 1, 2, 0.03. So times 0.03. Principal rate, interest rate, times time, 5 years. So I could do this a few ways. I can multiply all 3 together, but multiplication is commutative, so I could multiply them in any order I want. I'm going to just take that 5 times the 0.03 to get 0.15. 03 times 5 is 0.15. 3 times 5 is 15. Decimals over 2. Now that I have that, I'm going to go 2,000 times 1.5. Whoops, that's a mistake, not 1.5. That'd be too much. I'm going to do 2,000 times 0.15. That's going to give me 0, 0, 0. 5 times 2 is 10. Placeholder 0, 0, 0, 2. 1 adding down, I get 3. My decimal place is over 1, 2. My decimal goes over 1, 2. So how much interest will she earn after 5 years? $300 of interest is the answer. And hopefully that makes sense. It kind of makes sense. $2,000 is a fair bit of money. 3% interest isn't that great. 5 years, a fair bit of time. So it works out to be $300. You could do it either way. Whether you got money in the bank or whether you're borrowing money, the interest you would pay is the same, PRT, principal times rate. Okay, then here's our test on chapter 9, kind of wrapping it up right here. I'll pause the video for a second. Go ahead and work through these and I'll work through them. Again, the key is in the book. Okay, here we go. 5 more than a number. I don't know what that number is, so I'm going to call it X. This is 5 more than there. Twice a number decreased by 7. The product of a number and 3, product of a number and 3 is equal to 12. This is a tough one. Well, a number divided by 4 increased by 2. And then number 5, this is kind of a hard one. The first number is n. So if that was 7, the next number would be 8. So the next number would be n plus 1. Okay, here are a few distance rate problems. So for distance rate, again, we have distance equals rate times time. It's pretty similar to the other one I did. Let me do a different one like this. The distance is 220 miles in 4 hours. So that's what's given, and then it's asking for rate. So the way I use this right here, this equation here, I'm saying the distance is 200 miles. It is equal to the rate times the time of 4 hours. Divide both sides by 4 hours. It's an equation. These cancel. If I do that to the right side, I also do it to the left side. One nice thing about that right away, I see I have miles per hour, which is a rate, which is what I want. 200 divided by 4 is 50. So her average speed is 50 miles per hour, miles over hours. Let me move these up here. There's some harder ones here. A boat travels 48 miles downstream in 3 hours. So it is going downstream 48 miles in 3 hours. Let me just reduce that fraction. 3 goes into 48, 16 times. So this is 16 miles per hour. That's the rate traveling downstream. The speed of the current is 2 miles per hour. So the current in blue here, the current in blue here is 2 miles per hour. What is the speed of the boat in still water? Well, it's going downstream at 16 miles per hour. The current is pushing it of that 16 2. So it must be going 14 miles per hour. 14 miles per hour. Let's see if that even makes sense. I'm traveling 48 miles per 3 hours downstream, so I'm going fast. Part of that speed is the current pushing me. I figure that out as a unit rate per hour. so that's 16 miles per hour. The current's pushing me 2 miles per hour, so I must be traveling 2 miles per hour less than that on flat water. So the boat's powering me down 14 miles per hour. The current pushing me another 2. They sum together to give me 16 miles per hour. Okay, a couple interest problems here, and that's going to kind of wrap it up. Calculate the interest. So interest is equal to principal times rate times time. So calculate the interest earned on an investment of $1,000 at an interest rate of 5%. I'll convert that right to a decimal, 0.05, times time, 4 years. 0.05 times 4 is 0.2. 1,000 times 0.2. Maybe you could see that or multiply it out, but that's going to be equal to 200. So if you put 1,000 in the bank, it's still a good rate of interest, but for 4 years, the simple interest would be $200 right there. Okay, this one right here, 12 is a little bit harder. How much principal, so I'm looking for this principal here. How much principal must be invested at annual interest rate of 8%. So principal times 8% to earn $400. My interest is $400 in 2 years. So in this equation, I have 4 variables. Interest equals principal times rate times time. These are great algebra application problems. If I have these 4 variables, I have to have 3 of the 4. Well, I do. I have the interest I'm looking for, I have the time, and I have the interest rate. So I plug them in the appropriate places. Now I have one equation, one variable. P is what I'm looking for. Again, I'm going to do this 400. So I have 400 is equal to P. 0.08 times 2 is 0.16. Got to get my variable by itself, divide both sides by 0.16. That's going to give me my P by itself. So I have to do 400 divided by 0.16. I think of it falling over this way. So how many times does 0.16 go into 400? Well, I'm going to move that decimal over 1, 2. Go over 1, 2. 16 into 40 is twice. 32. 8, bring down the 0. 16 into 80 is 5. 80, 0, 0. Decimal point goes up. $2,500. So what I'm saying here, how much principal? $2,500 should be invested in an interest rate at 8%, pretty high, to earn $400 in interest in 2 years. So I would need $2,500 in the bank. All right, I appreciate you watching. I appreciate you supporting the channel. I'm kind of creating these new live classes every Wednesday, or I'll tell you when they are. Hopefully I'll post it a week ahead of time. I'll go over some ideas. Highly encourage you to buy that book, Math Test Success. Work your way through it. Again, just like I started on juggling, the more you practice, the better you get. That's just the way everything works. So just keep working at it, keep practicing, and you'll do well on any standardized math exam, knowing the foundations first and keep building on that. All right, thank you.